Alright, this is Unit 2, Quadratic Equations. This is Day 2, Simplifying Roots. On Day 1, we were solving by factoring, but we did see a couple of cases where we were able to use a square root to solve the equation. And today we're going to really focus on those roots because what I'm expecting from here on out is exact answers. So you might think to yourself when you see a problem like this one, square root of 18, when you get that as an answer, you might think, go ahead and type it in the calculator, you get like 4 point several values, it's irrational, and you might be tempted to write that down. I'm not expecting that. I'm expecting for you to simplify as much as you can. So taking a look at that process, what you're going to want to do is, since this is a square root, the power of the root is by default a second power, so square root, if you do not see anything written. You think of perfect squares. So 1 squared is equal to 1, 2 squared is equal to 4, 3 squared is equal to 9. And what I'm looking for is the largest one that will divide into what I'm trying to simplify. And I've actually gotten bigger than the number. So as I look at this list, the largest perfect square that will divide into 18 is 9. So the square root of 18, I'm going to rewrite that as the square root of 9 times 2. I am able to rewrite the square root of 9. Its principal root is 3. So 3 is no longer inside the square root, but inside the square root I still have the square root of 2 because I cannot simplify that any. The square root of 9 again came out as a 3. This is as simplified as I can make this expression, so I'm done with the problem. Might be a review for some of you. Some of you might still be a little uneasy about it. So there are lots of ways to do this process. I've seen it done with prime factor trees. I've seen it done with a calculator, in fact. So long as you're getting the right answer every time is really what I'm looking for. And if you want advice on how to do those other methods that you might recall, just let me know and I'll help you individually. Threw this one in here, and I really like this one because this reads as 3 times the square root of 72. This is not a cube root. You'll see what that looks like later when the 3 is written within the root. So you would see it something like the cube root. Something like that would be a cube root. Now getting back to this problem, the 3 times the square root of 72. What I'm going to do is same process. Since it's a square root, I'm going to think about my perfect squares. 1, 4, 9, 16, 25, 36, 49. And you don't have to write this down but once on your paper, and you can keep referring to the same list over and over again. There's 8 squared and 9 squared. The largest one that will divide into 72 is 36. So that's what I'm going to use. So I'm going to write this as 3 times the square root of 36. 36 goes into 72 twice. Now, square rooting the 36, that's going to be a 6. Now, what that's going to do is when it moves outside, it will multiply the 3, because remember how I was saying this is 3 times the square root. So it's going to read as 3 times the square root of 36 is 6 times the square root of 2. I can't do anything about. 3 times 6 on the outside is 18. So 18 times the square root of 2 is my answer. Now to talk about variables. It's actually the same process. Before we were getting perfect squares and getting them outside. Now, what is being squared to get you x to the 8th? It's actually, let me get my pen here, it's actually x to the 4th is being squared to get you x to the 8th. Now, what's being squared to get you y to the 5th? Well, y to the 5th itself is not a perfect square. So first of all, we're going to split it up, much the same as what we had done before. We're going to write y to the 5th as y to the 4th times y to the 1st power. Now that I've split it up, as I did with my numbers before this, I actually have a perfect square right here that will be able to get brought out. Y to the 4th, after all, is just y squared being squared. So now, what does this look like at the end? If I square root x to the 8th, it's really simple. Just divide the exponent by 2. 8 divided by 2 for the square root is x to the 4th power. You can also see it right here that x to the 4th squared, whenever you square the square root, they cancel out and you're left with x to the 4th coming out. Moving on to the next item, y to the fourth. If I were to square root y to the fourth, remember, just divide it by 2. So y to the fourth, divide that by 2 is y squared. A first power right here on this y cannot be divided by 2. It's a remainder, more or less, so it's going to remain inside the root. So my answer here is x to the fourth, y squared, times the square root of y, and I am done. So there is a cheat that you can do with your calculator to simplify square roots. It's kind of ridiculous, but it does work. This won't work for the x to the 13th. I'll have to deal with that by hand. But I can square root 288 and simplify it using my calculator. And what I'm going to do is I'm going to go to y equals, as you can see I've already done, and take that 288. And if you remember, we were dividing by perfect squares. So what I'm going to do is I'm just going to hit divide by x squared. So 288 divided by x squared. If you type that in y equals, here's what can happen. When you go to your table, second table, you will see possible answers pop up, such as 1 times the square root of 288, 2 times the square root of 72. But you're wanting the one that's furthest down the table that works out evenly. For instance, 5 times the square root of 11.52, that's not a good answer. 6 times the square root of 8 is pretty darn good, but as I go further down here, 12 times the square root of 2. That's actually how the square root of 288 simplifies. The square root of 288 is 12 times the square root of 2. And you can just refer to your table to actually get that answer. Now, could you have done that by hand? Sure. You could have found that 144 is the perfect square that goes into 288. It goes into it twice. And that's where this is coming from. Okay? That 144 comes out as a square root of 12. Alright, now, doing the x to the 13th, let's do 13 and divide it by 2 since it's a square root. 13 divided by 2 is 6 with a remainder of 1. Now, I'm going to show that out to the side really quick. 13 divided by 2 is 6 with a remainder of 1. Now, let's use that. So my final answer here is 12 x to the 6th power times the square root of 2x to the first power. You see that whatever the remainder is just remains inside x to the first power right there. So 12x to the 6th times square root of 2x. Time for some really important information to get dropped on you. While we're on the topic of square roots, we're going to talk about the imaginary unit, which is I, and it is defined to be that I squared equals -1. It's imaginary because with real numbers, that doesn't work. If you square a real number, you are guaranteed to get a positive value. We had to create this imaginary unit to describe certain situations in our world, like what happens with electrical current. And so in electrical engineering, they actually use this information to describe amperage and current, I believe. So I squared is equal to -1. So if you ever see the square root of -1, replace it with an I to represent the imaginary unit. And that's what allows us now to actually do the square roots of negative values. So whenever we look at example 5 here and we see the square root of -27, first thing I'm going to do is pull out the imaginary unit. So it's I times the square root of +27. Now I'll simplify it. Right now you could be using your calculator to get your answer by typing in 27 over x squared and y equals and going into the table. But you know, this one's a pretty easy one. I'm just going to say that 9 is getting multiplied by 3. And 9 being my perfect square, the square root of 9 is 3. So 3i times the square root of 3 is my answer. Alright, square root of 216. I'm going to get lazy again. I'm going to go ahead and do 216 divided by x squared. I'm ignoring the negative because that will just completely kind of throw things off a little bit. So now I'm going to go to my table and I'm going to scroll around for my best answer. And there it is. 6 times the square root of 6. I also know that this will have an I on it because it was a root of a negative. If ever the negative is outside the root, that is not what will cause you to have an imaginary number. So if the negative is on the outside, it's just like a -1 being out there, multiplying whatever you get to come out of the root. Going ahead and finishing this one up here, I'm going to go ahead and write it as I times the square root of 216. Those of you liking to do it by hand, the biggest perfect square that goes into 216 is 36. Goes into it 6 times. So I have now 6I times the square root of 6 is my final answer.